My name is Harsh, and today I will be giving a short presentation on the topic composition of atmosphere. So, in this presentation, I would be telling you about what are the various constituents of atmosphere, what is their significance, and how they play an important role in influencing life on the Earth. So, before starting about the composition of atmosphere, let me tell you about the significance of the topic. So, atmosphere is the layer of gases surrounding the Earth, and it is a really important constituent of the atmosphere for sustaining life form. And the study of atmosphere is done through the field of climatology. Climatology is derived from two terms, kilma and logos. Okay, so kilma means slope of the Earth, and logos means study. So together they mean study of the slope of the Earth, which means study of the natural gradient of the atmosphere of the Earth. So in this presentation, we would be going through the composition of the atmosphere. So atmosphere is a layer of air, as I have already told you, surrounding the Earth, and it is a really important component of of the Earth for life form. So atmosphere, lithosphere, and hydrosphere, they together make biosphere. It is the contact zone in which life survives. Life can actually happen. So the absence of atmosphere would mean no life would survive on this earth. So that is the significance of the atmosphere. Now, atmosphere extends from the Earth's surface to the height of 10,000 kilometers. Some scholars consider the height to be reaching up to 480 kilometers. And in general, all the atmospheric processes which are important, which impact our day-to-day life, happens just up to the height of 5 kilometers only. So the lowermost part of the atmosphere is really important, and it determines the life and activities on the earth. Now, atmosphere is composed of three components. Those are gases, solid particles, and water vapors. So these three are the important constituents of the atmosphere, and the atmosphere is divided into homosphere and heterosphere. Homosphere is the structure, is the zone where chemical compositions do not change. So the chemical composition of that layer would remain constant. So homosphere extends from zero sea level to 80 kilometers height, and heterosphere spreads farther above from 80 kilometers to 480 kilometers or 10,000 kilometers. And in this layer, there is a change in chemical composition. So lighter elements would be at the outer space margin, and heavier elements would be towards the surface. And homosphere and heterosphere together make up the gaseous composition of the atmosphere. So these are the three principal components. Now, water vapor, gases, and dust particles. So gases are divided into two, constant gases and variable gases. What are constant gases? Constant gases are those gases whose proportion does not change. So they will remain stable over a period of time. And what are variable gases? Variable gases would be those gases whose composition changes, whose proportion to the total gases in the atmosphere changes over the period of time. So we have mainly three constant gases: nitrogen, oxygen, and argon. So these three are the principal gases whose proportion is changed. They constant gases compose about 99% of the atmosphere, and the remaining 1% is the variable gases, where we have CO2, carbon dioxide, O3, ozone, hydrogen, helium, krypton, xenon, etc. So these gases together make variable gases. Now let's start with gases. So gases are the most important component of the atmosphere because they contain life-sustaining elements like oxygen, which is important for breathing, and it is on the basis of oxygen that we survive. Then we have hydrogen and nitrogen, which are important for plants. And so gases, as I've already told you, is divided into constant and variable based on chemical composition and its height. So constant gases would be those gases whose chemical composition as well as proportion would remain same, and they would be found in lower atmosphere. And variable gases would be those gases whose chemical composition and proportion changes, and they would be found at higher elevations. Okay. So, and one more thing, atmosphere or air, when it is removed of water vapor, dust particle, and variable gases. So the part which remains is called dry air. So means the constant gases, oxygen, nitrogen, and argon, they are called dry air. So these are the dry air is the largest proportion or constitute the largest part in the atmosphere. Now, these gases are governed by some laws. Okay, so due to changes in elevation, there would be change in pressure, which would lead to change in volume and density, and temperature also decreases. We know by normal labs rate that in the lower atmosphere, temperatures decreases at the rate of 6.5 degrees Celsius per 1,000 meters. So that would have an impact on volume and density of the gases as well. So there is always a change in volume and density, and these changes are governed by some laws. Those laws are called Boyle's gas law, Charles gas law, Lewis gas law, and combined gas law. So Boyle's gas law states that there is a relationship between pressure, volume, and density. If pressure would increase, volume of the gas will increase, and its density would increase. So this is how these gas laws are. They are not important here, but they would be more important when we study about the atmospheric scattering and the changes in basically the general circulation of the atmosphere. So these laws would come handy there. So now these would be the general introduction of gases. So this is the composition. So nitrogen is 79%, oxygen is 21%, argon is 0.9, which is around 1% if we round it up. Then we have carbon dioxide, neon, helium, methane, and krypton. So they together combinedly form 1% of the atmosphere. So this is how the gaseous composition of the atmosphere is. Now let's start with the largest constituent gas, that is nitrogen. So nitrogen comprises of 78.08%. So mean 78% of the atmosphere is composed of nitrogen. So being such a in such a large composition means it would have its significance, but that is not so. It is basically a filler gas. What it means is that it does not enter into chemical reactions with other gases very actively. Okay, so it is found in 7 forms in the atmosphere. The first one, N2, is the molecular form. The remaining three oxides are called oxides of nitrogen, like N2O, NO2, NO. And the last three, NH3, NH, and HNO3, are hydrogen nitrogen compounds. So it is the molecular nitrogen, N2, which is the largest in composition, and it is the most readily found form of nitrogen, while the rest are not in that much proportion when compared with N2. The last three, nitrogen hydrogen compounds, they are important part of the nitrogen cycle. They are usually found in soil, and they act as a fertilizers, and they are responsible for growth of plants. Now, now what is the significance? So nitrogen, NH3, and nitrates, they are useful by plants, and also nitrogen is an important component of amino acids. So amino acids are those acids which make up protein. So it is because of nitrogen that proteins can act functionally. So this is the significance of nitrogen. Now talking about the next gas. So the second one would be oxygen. Oxygen comprises 21% of the atmosphere, or basically 1/5 of the dry air is composed of oxygen. It was discovered by Joseph Priestley. It is highly active gas. It is highly active gas. It is responsible for combustion. So any elements when reacts with oxygen is oxidized, or when oxygen is removed from it, it would be reduced. And it is highly active gas chemically. It readily combines with other elements. It is produced by the process of photosynthesis by the plants. So naturally, oxygen is produced by the process of photosynthesis, and about 70% of the atoms in living matter is composed of oxygen. Life is not possible without oxygen. So that clearly proves it, since 70% of the atoms in living matter is composed of oxygen, and also we need oxygen for survival, for breathing. So that is why oxygen is a really important gas, and it is because of oxygen that respiration process continues. So it is the most essential gas, and also it is in the presence of oxygen that food is converted into energy in the body. So metabolism process also takes place in the presence of oxygen. So oxygen is a most important gas which is found in our atmosphere. Now talking about the third gas. So the third gas is argon. Argon comprises about 1% of the total atmospheric composition of gases, and it was discovered in 1874. It is not found naturally in the atmosphere. It is an inert gas. It is chemically inactive gas, and it it is a residue from slow decay of potassium, isotope of potassium. When it decays, it produces argon. And what are its uses? So it is used in bulb. So the tungsten filament in bulb is surrounded by, or the bulb is filled with argon gas to produce light. And also it is an important component of laser, and it is also used in welding. The next one would be carbon dioxide. Carbon dioxide comprises 0.035% of the atmosphere. It was discovered in 1752, and it is used in the photosynthetic process. So this is the most important uh, application of the carbon dioxide, because it acts as a carbon sink. Okay, and carbon dioxide is a variable gas, so it means its proportion changes in the atmosphere over a period of time. And what is the significance of carbon dioxide? So carbon dioxide helps in maintaining a constant temperature on the earth. So in the absence of carbon dioxide, what would have happened? The days would have been extremely hot and the nights would have been extremely cold, as is the case on Mercury. But carbon dioxide keeps the temperature at a constant level and helps in heating the atmosphere. So it maintains average temperature on the earth. But also what we have noticed in recent years is there has been an increase in the concentration of carbon dioxide over the years. This is because of the increased use of fossil fuels. So over the years, the proportion of carbon dioxide in the atmosphere, parts per thousand, is increasing, and it is leading to a phenomena where the heat trapping efficiency of the atmosphere is increasing, and that has led to global warming. So carbon's proportion if rises, it will lead to global warming. That is why there are numerous protocols on reducing carbon emissions, creating more and more carbon sinks. So the Kyoto Protocol was the first one of the number of protocols where serious steps about reduction in carbon emissions were discussed. The last gas would be ozone. So it is a triatomic molecule of oxygen. It is a gas which is faint with pungent odor. So this is a ozone layer, ozone gas basically, and it is formed in higher atmosphere, and it is very unstable gases. It is also variable gas, and it is really unstable. It is formed by the process where O2 oxygen reacts with incoming ultraviolet radiation. So what happens? O2 dissipates into two parts, O and O, two oxygen atoms, and when uh, the oxygen atom combines with oxygen molecule O2, it will lead to formation of triatomic molecule O3. So this is how ozone is produced. And also uh, O3 when reacts with UV, it will lead to reduction, and again O3 would be converted to O2 and O. So this process is continuous process. What this means is that continuously there is formation of ozone from oxygen, as well as reduction of ozone to oxygen. So this is a continuous process and it takes time simultaneously. So what is the significance of ozone layer? Ozone layer acts as a shield. It protects the earth from incoming harmful solar radiation. The shortwave radiation, which are very harmful, can cause skin cancer, blindness, and other diseases. It absorbs those radiation. So that is why ozone is really significant. But also it is a poisonous gas. So it is located at higher elevation, because of which it cannot cause harm to humans. So over the years, we have observed there is a hole in ozone layer, and why it is? Because there has been an increase in the in the composition of atmosphere. We have found that there is an increase in concentration of nitrogen, halogens, and halons gases. So these gases react with ozone and leads to its reduction. So more and more production of these gases would mean more and more gases would be available in the atmosphere to reduce the ozone to O. So because of which we have observed there is a reduction reaction going on, which is leading to ozone reduction. So uh, the Montreal Protocol of 1987 was the first protocol where the hole in ozone was addressed and significant steps were taken. So CFC production was reduced, and what we have found now is that the ozone hole has been healing and the ozone gap or ozone hole has been fulfilling. So that is why so it is a positive sign, and it is really important to have a good ozone layer, good health of ozone layer above the atmosphere so as to protect the earth from incoming harmful solar radiations. So these was all about gases that are present in the atmosphere. Now let's talk about the next component of the atmosphere, which is called water vapor. So water vapor is basically gaseous form of water. It is so water when evaporates, goes up in the atmosphere and is present as a gaseous form, which we call it water vapor. So water vapor varies in the atmosphere. So in cold polar areas, we would find that the water vapor composition would be about 0.2% of the total atmosphere in the cold areas. Whereas in moist tropical areas, water vapor would comprise about 5% of the total atmospheric compositions. So water vapor is really important gases, and about 90% of the total water vapor is confined to just 5 kilometers. So basically this 5 kilometers is for tropical areas, whereas in polar areas that height also reduces. So it would be around 2 kilometers in polar areas. And why this is so? Because convective activity take water vapor to greater heights in tropical areas, whereas this is not so in case of polar areas. So that is the reason the water vapor is found up to higher elevations in tropical areas in comparison to polar areas. So what we also know is that 90% of the water vapor would be confined to the height of just 5 kilometers. So 90% water vapor below 5 kilometers. It is because it is heavy to transport it upwards. So what it does is it absorbs outgoing terrestrial radiation. So this is the important significance of water vapor. It absorbs outgoing terrestrial radiation and leads to heating of the lower atmosphere. So it is also one of the greenhouse gases. The next and the last is the dust particles. So dust particles are collectively the liquid particles and the solid particles are collectively called aerosols. Aerosols, what they include, they are basically dust particles which are present in the atmosphere. Like how do they reach? They are basically about volcanic dust, breaking sea waves. So salt is carried, ash and soot from combustion process, organic matter like pollen grains, and meteoritic dust which enter the Earth's atmosphere. So these are basically the aerosol components which are found in the atmosphere. And the significance of dust particles is that it also is an absorbent of incoming and outgoing solar radiation and terrestrial radiation respectively. And it is also acts as an hygroscopic nuclei. So it acts as nucleus around which water vapor condenses and leads to formation of clouds. So this is the important significance of dust particles. Also, it helps in scattering of lower atmosphere. So the diffuse daylight, the Rayleigh scattering, the Mie scattering, these type of scattering of radiation takes place because of the presence of dust particles in the atmosphere. So dust particles when present in large number would lead to formation of clouds, and that would reduce the incoming solar radiation to the atmosphere, and in this way it would lead to cooling of the atmosphere. So this was all I wanted to tell you about the composition of atmosphere in very brief, and I hope you would have understood what I tried to say. Thank you so much for this video. Thank you.